Hello, in this video we're going to be starting the game engine setup. We're going to be starting off with the state machine. So what is a state machine? Brief overview of what a state machine is. You have states in your game, and these can be states such as the main menu state, the game state, let's say game over state if like the players died, and you could have like a splash screen state, so you would show off, let's say, your logo, your company's logo, any sort of intro video, that sort of stuff. So that's what a state machine is. You might hear states being called as screens or even views. It's essentially the same thing, it's just a different part in the game. And if you Google state machine, you'll get a bunch of diagrams, you'll get a bunch of great links that explain state machines in more depth. But what we're using it for is, the main purpose of it is to switch between different states in the game. So let's implement this. So the first thing we want to do is actually create a state file. So what we want to do is right click our project. If you're on Visual Studio or anything else, that's fine. I'm sure you know how to use Visual Studio or whatever IDE or text editor you're using. Just create a file in the normal way and just compile it in the normal way that we showed you in the setup video. So refer to that if you have any queries, or you feel free to message me directly. So I'm going to click New File, and what you want to do is select Header File. Again, if you're on Visual Studio, process will be very similar. And I'm going to name this state.hpp. I'm going to add it to my target, my project, and in here I'm going to get rid of all of the contents. Let's maximize it a bit. I'm going to do hash pragma once, so it will only be included once. Do a namespace of Sonar, which is my company name. You can change this up, but it's good to have a namespace. Good to keep our classes separate from, let's say, some other external libraries. You could have your name here. I like to use my company name, or the first word of my company name, I should say, Sonar from Sonar Systems. We're going to have a class called state. It's going to have public methods. First one is going to be a virtual void in it, and this will, you can guess, initialize the state. Then we'll have a virtual void for handling input, and I think you can guess this will handle all input on that particular state. Virtual void update. This will update any like variables that you have, anything after you've got input from the user, you will update your particular game. So let's say if you have a game where you have a player, you get some input like the up arrow being pressed, then you could update it in the update method to move the character up one space. This is going to equal to 0, and then we're going to have another virtual void. This is going to draw. So after you've handled input and you've updated anything, it will draw your application, and this is going to have float dt, which is delta. That's just the time difference between frames. This just allows us to create frame independent gameplay by factoring in the frame rate, which is fantastic, because you don't want, let's say if you have a device that can run your game at 60 frames per second, you don't want it to run twice as fast as a device that can run it at 30 frames per second. You want it to be smooth, or you want the actual pacing to be the same. Now we're going to do a virtual void pause, and this would just simply pause your game, or this will be called when you're pausing the game. Resume. This doesn't necessarily resume and pause, we'll have separate stuff for that. So if we save that, that's all done for the state class. We now need to have a state machine class which will use our state class. So I'm going to go back to here, add another project, or another file. I'm going to add a C++ file, and this is going to be state machine.cpp. You want to create a header as well. If your IDE or your text editor doesn't have that option, just create one separately, add it to your project, to your target, and in the HPP what I'm going to do is get rid of all of the contents, maximize my space a bit, put hash pragma once again, always good to do this in the header file, do hash include memory, we'll be using the function from the memory library, and do hash include stack. The states or the state machine will be based on a stack, so the top state will be the one that is running, and then we can pop that off. So for example, if it's paused, we could pop it off and we'll get back to the game scene. Now we're going to do hash include state.hpp. Now we're going to do the good old namespace sonar, and now we're going to do type def std unique pointer, and this is going to have a type of state, and we're going to call it state ref. We'll be explaining all of this later on in this video and in future videos, how it works and what it's doing. So now we're going to create a class called state machine, which will handle all of our states and what's running, what input is being handled for what particular state at any given time. So this is almost like the backbone of our application. Now we're going to have a few public methods. First one is going to be a state machine constructor, and we're just going to leave that empty. We're going to have a state machine destructor, I'm going to have a method called add state. I think you can guess what this does. This adds a state onto the stack, and that will be the latest state that is running. Everything else will be paused. And we're going to have a bool that is replacing, and what this means is, are you replacing the current state that is already available? So for example, if you're on the main menu state and you click the play button, it takes you to the game state. You don't want the main menu state to exist anymore. You could go back to it from the game state or a pause state, that's fine, you will create it again. But because you don't need it anymore, there's nothing there that's persisting, you would put this as true. By default it is true because we've assigned it right here, and this would replace that state with the current state. Instead of just adding it onto the stack, it would essentially pop the old state off, then put the new one on. Now we're going to do one called remove state. So if you want to manually remove the top state, you can call this method, and we're going to have one called void process state changes. And this runs at the start of each loop in the game.cpp file, which we will be creating in a future video. So what I'm going to do is just have some empty lines so it's easier to see and easier to scroll up and down. We're going to have a state ref, which is going to be a reference, so it's going to return a reference to the get active state. So this will return the top level state, and that's what we'll run in terms of drawing, handling input, updating the game logic. Now we're going to have some private variables, and we will need a stack, and the type is going to be state ref that we created above, which is essentially a unique pointer to a state. And this is going to be called underscore states. So this will be all of the states that are presently on our stack. State ref is going to be underscore new state. So it's going to be the latest state to add. And we're going to have a variable called bool underscore is removing, and bool underscore is adding, and bool underscore is replacing. So this just tracks if we're removing a state, if we're adding one, or if we're replacing one, and that way when we get to the next time when we process any state changes, we know what we're doing. So now that we've implemented the header file or created the header file, we now need to implement it in the CPP. So go ahead and open the CPP file. Let's get rid of, I can just get rid of the comments actually, because I still need the HPP include file. Do a namespace of sonar, and in here we're going to do void state machine, add state, state ref, new state, and bool is replacing. So now we need to implement the add state method. Pretty simple. You will just do this underscore is adding equals to true. This underscore is replacing equals the is replacing parameter that has been passed in, or by default it is true. And then this underscore new state equals to std move new state. So it's a very simple method for adding a state. The next one we're going to implement is removing it. So state machine, remove state, and this is going to be this underscore is removing equal to true. That's all you need to do in this method, because we'll handle any state changes in the next method that we implement, which is, let me actually add some empty lines so it's easier to see. This is going to be void state machine process state changes. First of all, we're going to check if this underscore is removing. So if is removing is set to true, and this underscore state dot empty is not true. So if there are states and the is removing is set to true, then what we need to do is, well, pop the state. To do that, you just do this underscore states dot pop, and now we're going to check again if the states are empty, so if there are any states left. If it's not empty, what we're going to do is this underscore states dot top. So the top state, that's the one we're going to run. We're going to do resume. So we're going to resume the next state, which is now the top state. Now we're also going to do this underscore is removing equals false, because once we removed one state, we don't want to keep this as true, because this will just keep removing every single state till we've got no states left. Now we need to check for if this underscore is adding. So if we have set the is adding variable to true, that means we want to add a state. And now what we're going to do in here is if this underscore states is not empty, then we're going to run the following code. First of all, we want to check if is this underscore is replacing. That means if we want to replace the current state, then we're going to do this underscore states dot pop, so get rid of the current state. So we don't directly replace it, we initially take off the current state. If we're not replacing it, all we do is this underscore states dot top, we pause it. So we don't want it to run anymore, but neither do we want to get rid of it. And finally, outside of this if statement, we can actually start adding on our state and initializing it and getting it to run, the new state that is. So we would do this underscore states dot push, and the state we're going to push on is std move. So we're going to move the new state onto it, new state, this underscore states dot top, and we're going to do init, which was within our state class that we created before. So we would initialize or call it init method, and this allows us to initialize the state. So if we're setting any variables within the state, if we're loading any textures, any of that cool stuff. Now we're going to do this underscore is adding equals false. So we are going to set this to false now because we don't want to keep adding a state. And finally, we need to handle the get active state method. To do that, remember it's just a state ref. We're just returning a references state. So state machine : get active state. To return this, all you do is return this underscore states dot top. Remember, we're only interested in the top state because that is the active state. And now if I were to build this, this successfully builds. The only one last change we need to make now is in the main.cpp. We can get rid of all of this. We can get rid of all of the contents within the main file. And format it a bit better. Actually, the only thing we do need is a return statement. So return exit underscore success. You might be wondering, why have we got rid of everything when we set it all up? Okay, so this is use of undeclared identifier, hash include iostream. Okay, we got return exit underscore success working now. So if I were to build it or run it, let's say, there you go, it successfully runs. Again, you might be wondering, why have we got rid of all this code when we spend all our time setting it up? The setup was great, we needed to do that, but having all that code in the main, it's not very good. That's the whole point of creating this game engine. The next few videos, including this one, is all about creating a game engine. So the main is simple. We've abstracted out the functionality from the main into separate files. We've got a state machine with states now. We'll have a game class. We'll have an input manager. We'll have an asset manager to handle all of the different facets of our game. And then we can actually get on to implementing the game. And the beauty of this is once you've got the game engine setup part done, you can reuse that game engine again for the states, the input, for the asset management, for all that good stuff for your next game. You don't have to do all that again. That's the fantastic thing about it. So if you have any questions, feel free to post them on my education platform, sonarlearning.co.uk, or feel free to communicate via Twitter, Facebook, Google+, or any other way that you feel comfortable with. All the links that you need, such as the source code from this tutorial, will be available with this video. And as usual, thank you for watching, and I hope you have a wonderful day.